In this section we delve into volume for the first time. Most of you probably already know this, but we need to go over exactly what volume is first. When we did area, we were calculating how many squares could fit inside of a shape. On the screen here is a rectangle. Let's say I decide that this will be what one square unit looks like. Then I would want to know how many of these little square units make up this shape. That's even why it's called units squared. We are literally counting up squares. For this rectangle here, we have 12 of these square units that fit inside of the shape. That was for area. For volume, we aren't counting up how many squares fit inside of a flat shape. We are calculating how many little cubes a three-dimensional shape is comprised of. Since we are counting up cubes now instead of squares, every volume calculation should be units cubed, not units squared. Whether that is 17 inches cubed, 29 centimeters cubed, 24 units cubed, or whatever, all of your volume calculations should be units cubed. It's right there in the name, units cubed. We are counting up cubes. We will start off with the easiest formula, a cube. If we know a cube is a symmetric shape where all faces are congruent and all edges are congruent, we often label the edges E. If that is the case, then the formula for the volume of a cube is simply E cubed. That's it. I told you it was the easiest formula. If an edge of a cube is 8 inches, then you simply cube it to get 512 inches cubed. But these volume cube problems bring up this issue for the first time. Consider this problem. We have a cube which we are told has a volume of 2,197 centimeters cubed. We need to figure out the length of an edge. Since we were given the volume of a cube, we should start out by writing down the volume of a cube formula. Then we need to plug in the number we were given. But now what? Students are often stumped at how to proceed from here. It's the first time many people have encountered this before. When you had a variable squared, you probably knew how to proceed. If x squared equals 25, then you took the square root of both sides to get the answer of 5, assuming this is a question that didn't need the negative answer. But you took the square root of both sides to cancel out a square. A square root canceling out a square. It probably isn't a coincidence that they use the same name. Here we have a cube, E cubed. In order to cancel out the cube, I need a cube root, which looks like this. The cube root will cancel out the cube and leave us with an answer of 13. The edge of our cube is 13 centimeters long. Now I don't know which calculator you are all using, but you need to know how to take a cube root on it. You should try it out with the 2,197 to make sure you get 13 as an answer. I will show you how the TI-84s do it now, since they are the most common one. Here's the TI-84. On the left side of the screen we have a math button. If you click on the math button, the fourth option down is our cube root. You'll notice the little 3 in front of the square root symbol. That's the one we need. You hit enter, and on the screen will pop up our cube root. You then put in 2,197 and hit enter, and there we go, that's our 13. Now we get to the formula for a volume of a prism. The volume of a prism is BH. Capital B once again stands for the area of the base. So you take the area of one base and multiply that by the height of the prism. In this prism here, if I assume the shaded face is one of our bases, we would first calculate B. The base is a rectangle, so we do base times height to get 450 for the area of the base. We can then plug that into our volume formula. We multiply that 450 by the height of our prism, which happens to be 36, and our final answer is 16,200 inches cubed. Don't forget those cubed units in your final answer. This is probably going to sound awfully familiar to you by now, but cylinders are so similar to prisms that they can use the same volume formula as a prism. But once again, you get to choose whether you want to use that formula or whether you want to memorize a cylinder-specific volume formula. For a cylinder, we know the base is a circle. We know the area of a circle is pi r squared, so we can substitute it in. It is up to you whether you want to memorize the extra formula or not. And finally, you will see problems that deal with composite space figures. Some people think that sounds a bit weird, but all it means is that we have a composite three-dimensional figure. In any case, what does that mean? Well, before you had problems that gave you odd-shaped figures to find the areas of. I doubt you remember the name, but to solve these kinds of problems you used the area addition postulate. To say that you could chop it up into pieces, that you could find the areas of all those pieces, and then add them back together to get your answer. We are going to be doing the same thing here, except in 3 dimensions. A composite space figure is simply one which can be chopped up into more manageable pieces. Consider the iconic Hollywood sign. Let's say we want to find out the volume of the letter H. How much stuff did it take to make that H? Amazingly enough, we don't have a formula for the volume of an oversized 3-dimensional letter H. However, even though we are lacking that, we can chop that H up into 3 prisms that we could find the volumes of, just like when you chopped up the shapes with the area addition postulate. You'll be doing the same kind of thing, just in 3 dimensions now.